What's up, everyone? In this video, we're going to be talking about surface area and lateral area of prisms and cylinders. So, some content refresher, you've probably seen surface area before, but just to refresh our brains, the surface area is the area of every single surface of a 3D shape. So a fancy mathematical way to word this is that the surface area is the area of the net of a figure. Now, when you think of a net, you probably think of like catching fish or a basketball hoop or something like that, but in geometry, the net of a figure is a term used to describe what a 3D shape would look like if it was opened out and laid flat. So in this example, we can see that we have a cube here, right? It's all folded up nice to make a 3D figure, but we can cut all the sides and lay it flat out, and this right here, that is the net of a cube. And what the net will help you do is you can see what surfaces make up the shape. So for example, we can see we have 1, 2, 3, 4, 5, 6 squares, right? So the net is going to help you figure out the surface area, because for surface area, you need the area of every single face of the shape. So when you have the net of a figure, it helps you see, hey, what actually makes up my shape, and then you can find the area. Now, the new vocabulary word that we are learning is called lateral area. So the lateral area is the area of every surface, so similar to surface area, except we are not accounting for the bases when we're doing our lateral area. So another way to word this is we're going to find the area of our lateral faces. So the lateral faces are every single shape except the bases. So this is a nice little visual. So in this example here, we have a cylinder, right? And shaded, we can see that the lateral area, if we wanted to actually calculate it, we'd just be considering this shaded region here, not counting the top and the bottom, right? So you have a base at the top, and you also have a base at the bottom. So that's kind of something to keep in mind as well, right? Now, if you wanted the surface area, right, you're shading in everything. So not only are you shading in the lateral face here, but then you'd also be accounting for the base at the bottom and the base at the top, so that you're shading in everything. So this is a nice little visual to help kind of conceptualize what lateral area is. Now, some real-life examples of surface area and lateral area are as follows. So if you want to wrap a gift for somebody and you need to know how much wrapping paper you need, right? That is surface area. You are covering every single face of that object, hopefully, with some wrapping paper. Otherwise, some things are going to be exposed and people will be able to see what their gift is, right? Another example, and I don't really like this one too much, but it's a good conceptualization of this. So if you want to ice a cake, typically you don't ice the bottom, but let's say in this example we are, right? You ice the top, you ice all the sides, and let's just say for this case that we ice the bottom to make sure that it stays on the platform. And then something else is finding out how much paint we want to cover an object, right? So this picture is a house. House isn't the best example. Let's say you want to paint a box, or you want to paint a gift for your mom or something. You want to cover all of those faces with the paint to make sure it all looks good, right? So some examples of lateral area, right? If you want to find out how much material you need to make a label for a can, right? Like Pringles or soup, right? They don't put a label at the top base and the bottom base. They only put a label around the lateral face of the can, right? So that is lateral area. And then finding out how much material is needed to make a toilet paper roll is another example of lateral area, because we're not putting that cardboard material in the circular bases, right? So in class, when we come in, we're going to be exploring what makes up the net of all of these 3D figures here, because we need to know what the net looks like so that we can figure out what the surface area is and the lateral area is. And what that's going to help us do, if we can conceptualize this and kind of visualize what the net looks like, then we're not going to have to remember a bunch of these formulas, right? Because surface area is the area of all the faces. So if you can figure out what shapes the faces are, you'll be able to find the area, right? So we will explore this more in class, so make sure you have your definitions down, and we're good to go.